In this video, we will be learning what a three-variable system is and what its solution actually represents in mathematics. So a three-variable system is very similar to a two-variable system. A three-variable system, as it kind of seems, has three different variables. You can see here that we have x is one of our variables, y is another one of our variables, and z is our third variable. And our goal when we're solving a three-variable system is we want to determine what values of x, y, and z make all three of these equations true. So because we have three different variables in here, we also have to have at least three different equations to find those variable values. Now, the last thing we want to talk about is what our solution to a three-variable system will look like. And our three-variable system will be what is called an ordered triple. So it looks like a coordinate point, but it's got three coordinates. And we'll talk about why on the upcoming slide. And you'll always list them as x, y, z. So before we start solving these, I want you to really know what that ordered triple really represents. So with the two variable systems that we've solved before, we are finding the point of intersection between these two lines. So when we had our x, y coordinate point, that identified this point of intersection. And when we're solving a three-variable system, we're really doing this exact same thing, but we're doing it in three dimensions. So here you can see we have an x, y, and z plane, and we have those big planes because we're in three dimensions. And what we're trying to find here is this ordered triple point, so x, y, z value, where these three planes actually cross. So that ordered triple represents a point of intersection, but because we're in three dimensions here, we have to have three variables as a part of that point. Now, as we talked about in 2D, when we had two variable systems, we also have situations in 3D where we have one solution, no solution, or infinitely many solutions. So on the previous slide, we talked about when we have one solution, we're finding this ordered triple point that is x, y, z. So we're finding that one single point where all three planes cross. Now, if we look at this second example here with the infinitely many solutions, hopefully what you're noticing is that these three planes cross a little bit differently. Here we had a single point that all three of those planes crossed at. If you look carefully here, we actually have a line. So the way that these are intersecting is very unique. They're not intersecting at a single point, but instead they're intersecting at a plethora of points. There's multiple points that these planes have in common. And when they have multiple points in common on a line, like I drew here, that is called infinitely many solutions. And then finally, we have situations where maybe all three planes don't cross. So here you can see none of the planes cross. In this picture up above, you can see that the pink plane crosses with green and blue, but the green and blue planes don't cross each other. And here you can see that pink and green cross, pink and blue cross, and green and blue cross, but they don't have a point where all three of those cross. So if all three of them do not cross, you're going to find that your system has no solution. And we're going to see all three of these cases as we solve our three-variable systems.